Okay, on to the second page here, where I have got vectors to add. In this case, they're clearly in rectangular form because there's no degree up there. There is a degree symbol here, so these are polar. So I just add the x values. That is going to be 13. And then I add the y values, and that is 4. So that resultant would be 13, 4. You can think of it visually. Over 5 and up 7 would be a vector like that. And then over 8 and down 3 would be a vector like that. So if I pick this vector up and put it down, it's going to be something like that. So this would be the resultant vector. And it makes sense that it's like over 13 and up 4. All right? So I'm not asking you to do that, but just that will help with your understanding. All right, this is one of the key problems because what we have to do is convert this into rectangular form like this so that we can add them as we did. But then once we're done, we have to go back and reformat this in polar form. So it helps to have a little picture, I think. 5 at 70 degrees is going to be like that. 8 at 280 is 270 is all the way around to here, so 10 degrees more is going to be like that. Okay, so I'm adding these two vectors. If I pick this one up and put it there, pick this one up and put it there, this is the parallelogram method. My resultant vector, I'm guessing, is going to be in the second quadrant, something that's going to be maybe a little bit more than 100 degrees. All right, so I'm going to break each one of these down. If that's A and that's B, A in rectangular form is going to be equal to 5 times the cosine of 70 degrees, and then 5 times the sine of 70 degrees. All right? And then the B vector in rectangular form will be similar, but with different numbers. 8 cosine of 280. And this is a nice formula because it just works every time. 8 times the sine of 280. Okay. Well, when you get that, and I guess I can very quickly do it, I'm just going to add the x's. So in one fell swoop, I'm going to do 5 times cosine of 70 plus 8 cosine of 280. And hit enter, and I get, when I add these up, the resultant is 3.099. So 3.10, I'm going to call that when I round it. I'll do the same thing here. I'm going to do 5 sine of 70 plus 8 sine of 280. And hit enter, and I get negative 3.18. Now you'll have slightly different numbers. I've done them quite accurately. So what that means is my resultant is going to be 1, 2, 3 and a little bit this way, and 1, 2, 3 and a little bit that way. So it's going to be almost a 45-degree angle like this. All right? Well, I need r and theta. And the way you do this is x squared plus y squared square rooted. And then it's going to be the inverse tangent of the y value over the x value. And then you have to use the appropriate quadrant. All right? So, and I drop off any negative sign because I just simply need to make this into a right triangle. Like this. There's my right angle sign. This is my x amount. This is my y amount. And I need to figure out what this theta is here. That's my reference angle. And it's always the angle that's made with the horizontal. Okay? So if you need to pause and listen to that again, do so. But I'm looking always for a reference angle. So I take and I do inverse tangent. And I put the y, 3.18, I drop the minus sign, 3.18 divided by 3.1. And I get 45.73 degrees. So theta, right here, theta equals 45.73 degrees. Then my actual angle for polar is going to be 180 minus that. So it's going to be 180 degrees minus 45.73 equals 100 and 34.27, all right, degrees. Then when I square these, add them up and square root them, 3.1 squared plus 3.17 squared, or 1/8, it's close enough, is going to be 1965, and I square root that, and I get 4.43. So this is 4.43, comma 134 point, I'll round that to 3 degrees. That is the final answer. Just remember that you're going to get a different result based on what quadrant you're in. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Okay? So if, for example, I'd found some answer over here, I would find this reference angle and I'd subtract it from 360. If I'd found an angle over here, a vector that resulted over here, I'd find this angle and I'd add it to 180. If I'd found it in this quadrant, whatever theta I'd found would just be the angle that I'd rotate. So beware of those 4 different answers for 4 different quadrants. All right. On to this. Find all the missing sides and angles. Start with a rough draft if you need to. This is 23 degrees. It's approximately correct. That's A. Then the measure of angle B over here, if that's the right angle, I'm going to go a little bit less than a right angle. And I'm going to sneak that in there. This is 87 degrees. I can add these up and subtract it from 180. Those add up to be 110. So this is 70 degrees up there. This is my side A. Opposite 87 is side B. And this is C and side C right there. Okay, this is a angle side problem, or angle side angle. Which is it? Because I know that C is equal to 15, so that means it's angle side angle, because I know this angle and the side right here trapped in between. Angle side angle is law of sines. Law of sines, because it is not side 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 or side angle side, which is law of cosines. So now I just simply write this with its opposite. So I'm going to look for the other sides. So I'm going to say A over sine of 23 is equal to C, 15, over the sine of its opposite, 70 degrees. And then I just do the math. In this case, I'm going to multiply both sides by sine of 23. All right? So I take and I put in 15. I divide by sine of 70. When I get that answer, I'm going to multiply by the sine of 23. And I get 6.24. So A is equal to 6.24. All right? Then B, I find the same way. B over its opposite side, 87, taking the sine of that, is going to be equal to 15 over sine of 70. Okay? So once more, if I do 15.96 is my original 15 over sine of 70, and now I'm going to multiply this by sine of 87. And I get 15.94. So B is equal to 15.94. All right? So you've got your 3 missing quantities there. I've given you 3, and I've found the 3 missing ones out of the total of 6. Similar problem here, only different. This is a side, and a side. So this is clearly law of cosines. Know that a sketch helps. Approximate sketch. If this is 20, this could be the 11, this could be the 15, and that's pretty close to being accurate. Opposite the 20 is A. Opposite the 15 is B. Opposite the 11 is C. I'm going to start by finding the biggest side first. That's the best way to go because you're not left trying to have your calculator undo an angle that's more than 90. That's tough. This one will always work with the largest side first, longest side first. So 20 squared is equal to 15 squared plus 11 squared. Then minus, this is the Pythagorean theorem, minus the adjustment 2 times, and then each of these sides, doesn't matter what order, it's just multiplication, then cosine of the angle A in this case. And that's the one thing I don't know. So 400 is equal to 225 plus 121 minus 30 times 11 is 330 cosine of A. All right, so now I add these guys, and that is 346. So 400 equals 346 minus 330 cosine of A. I'm going to subtract 346 from both sides. And I get then, what is that, 54 equals negative 330 cosine of A. Well, I just do the math like you've gotten pretty good at, I hope. And A then, angle A is going to be equal to the inverse cosine of, and when I divide both sides by negative 330, negative 54 over 330. And that will give me angle A. So I do second cosine. And then, what is it? 54 divided by 330. And I hit enter, and it gives me 80 degrees